Welcome to topic 1 in our unit on space. We're going to deal with understanding how we might use different points or frames of reference in the sky to help us pinpoint or navigate things. The universe is a very large and daunting thing. Let me see if I can walk you through the scale of our universe. Let's start really big. So this huge thing is trying to show you so far what we know about our universe, and it's called a supercluster, made up of many galaxies. So let's blow up this local group right here. So let's make this bigger. And within that, we have several different galaxies smaller down. And if we blow up this one right here, this is our galaxy, the Milky Way. So let's blow up the Milky Way galaxy right here. Then let's pinpoint one small section down here of that, and this collection of stars is just one tiny pinpoint within the Milky Way galaxy. And so here it is, and so this is the neighborhood that our star, the sun, is in. And so let's blow up that, which is there, and that makes up our sun and the solar system that encompasses it. And so that gives you an idea of the scale of things in the universe. Further to that, let's go to a website that I found that does the same thing. So this has given us an idea of the scale of the universe. We're going to start at the human level and what we might see. So within the circle, the Rubik's cubes, a cup, etc., ostrich egg. And let's zoom out. We can see a beach ball, a house, a bus, an airplane, towers, the Sears Tower, Angel Falls. Let's keep zooming out. And now we're into sizes of some asteroids. Pluto, Mercury, Mars, Earth and Venus. There's Neptune in size. And our sun. A few other types of suns as we zoom out. Different stars. Now we can deal with solar systems and then nebulas. There's the Cat's Eye Nebula, different nebula. Clusters of stars. Zooming out, galaxies now, so we're getting large galaxies. There's our Milky Way galaxy, as I talked about. Oops. And then we get local groups. And finally, the universe. So let's talk about how we find the frame of reference of things in such a complicated sort of network of information. So let me go full screen. So years ago, as cameras started to develop, people used to think that the sky was spinning and that the stars revolved around the Earth. And so if you see this time-lapse photography picture, you see that these swirls indicate that maybe we were at the center and everything else spun around us. And what we really realized was that when we look out into the sky, is it us that's stationary, or are we moving and it just appears that we're stationary? And so if we zoom out and look at how the celestial sphere looks with the Earth sort of in the middle, we can see that the Earth is tilted slightly on its axis. And the center of the Earth points to something called Polaris at the top, at the north end. Right up here, Polaris. But when we're standing and we look straight up, we're looking up to something called the zenith. If we're in the south, there's no southern star, but there is, if you're in the southern hemisphere down here, there is the Southern Cross, which is what you would see here. The center of the cross would be right there, and so the axis would be pointing there. So ancient people used to imagine that there were these patterns of stars that were called constellation. And officially, I think there are 88 constellations that they used to use to help predict things happening. Now, we don't have to know all the different constellations, but we should be aware that they're there. And so let's keep going. It was difficult then for us to try and talk about where something was in the sky when the sky seemed to be moving all the time. And so we had to come up with a way, especially for those that were using the sky as a method of navigation, like often mariners, people on ships used to do, because if they used a constellation, what we found out was the constellation in any given time could move. For example, the Big Dipper in the sky isn't in the same location in a 24-hour period, nor is it in the same location over the course of the days in 365 days out of the year. So we needed a new method to try and navigate and pinpoint things, which came to the following. We use now something called the azimuth and the altitude to help us track things in the sky and to help us pinpoint directions and so on in space. And so let's look more at the concept of what the azimuth and the altitude is. Now straight up, if you're standing on the horizon and you look straight up, that point straight up above the Earth is called the zenith. Remember, the Earth is tilted slightly, and so right there would be the North Star. So let's say you wanted to show someone an object in the sky at night or even in day. How would you say look here or look there? Well, step one is to get them to point in the horizontal direction that you need. So from north on our compass, we can use a compass bearing and we can give them a compass direction going horizontally 360 degrees. So if you start here and you go all the way around, that's 360 degrees. So that clockwise from north, we can use the azimuth angle, and we use a compass to help us tell what the azimuth is. But what about how high above the horizon we look? Again, let's get a good picture. Here's me standing on the earth, and when I look straight up, I'm looking at something called the azimuth. Whereas the North Pole is actually tilted slightly, and it's pointing at the North Star. And in the southern hemisphere, if you're down here, it's pointing at the center of the Southern Cross. So we're angled. The Earth is tilted just slightly. So what can we do? Well, the second device we use to measure how far up from the horizon, we know how far along the horizon, but we don't know how far up. Well, we came up with an idea, and it is called an astrolabe. An astrolabe measures the amount of elevation above the horizon using degrees to get us to pinpoint where above the horizon we need to look to find the star. And so this would be 0, and then depends. It looks like this is about 45 degrees from the horizon. So if we have 2 of those, we should be able to pinpoint an object in the sky. So let's see if we can practice this. We need to identify stars in this celestial sphere here based on coordinates. So there are 1, 2, 3, 4, 5, 6 stars. And let's see if we can, using the azimuth, which is the angle clockwise from north, using a compass, and then using an astrolabe, the altitude, which is the angle above the horizon, we should be able to find them. So here's north. So that's my line to help me with my azimuth. And then, so let's see, what star is due west and 40 degrees above the horizon? So starting here, never eat shredded wheat, there's west, so due west and 40 degrees above the horizon. So that's from here up 40 degrees, and that looks like it would be star A would be at those coordinates. Okay, what star is southeast and 10 degrees above the horizon? Here's north, southeast, so this is just past, and it's barely above the horizon. So star E would be southeast, so just past there, and then a measly 10 degrees right here above the horizon. So that would be star E. And what star is due north and 53 degrees above the horizon? So due north would be 0 degrees for azimuth, so straight north, and quite a large angle. So the only star that's 53, or that's due north, is C, so that's got to be star C. Star D is, think of this as a sphere, so star D is on the other end of this sphere. Okay, so it's past this east mark. So keep in mind that this is 3-dimensional. So hopefully that gives you an idea of how we can help track things in the sky by putting coordinates on them called the azimuth, which we use a compass for, and the altitude, which we use a device called an astrolabe for.